Hi, welcome back. Today we're going to look at 3n plus r rules because they have some pretty crazy loops like this one. So we've been trying to rule out 3n plus 1 loops or find a counterexample, and we've looked at data asking ourselves what conditions need to exist for an integer loop like this one. Does the length need to be prime? Does the smallest member of the loop need to be prime? Does it need to be of the form 2n plus 1? Is there something about this loop shape that's special? We know that certain loop shapes can't be counterexamples, like the high loop shape. If 485 over 13 and 421 over 13 were both integers, then their difference would also be an integer, but it's not. Now, does every loop shape include such a pair of numbers whose difference is 2 to the y? Definitely not. But notice that 485 and 421 are also coprime. And that means some linear combination of them equals 1. So if 485 over 13 and 421 over 13 were both integers, then this would also be an integer, but it's not. And overall, any pair of integers has a 60% chance of being coprime, so maybe we could show that every loop contains at least one pair of coprime numerators. But first we better check if that's true though, and turns out it's not true. If you look hard, you can find loops like this, where every numerator is a multiple of 7. It's a kind of pseudo-loop. And the reason this happens is there's a factor of 7 in the denominator. So if we take the bottom loop member here, multiply by 3, add 1 over 2, the fact that there's two 7s here ultimately gets us to the next loop member, which is here. And, we're not lucky enough here to cancel the whole denominator, but at least we canceled part of it. So whenever the denominator is composite, we seem to get the expected number of pseudo-loops. Like in this case, almost every 7th loop shape of this length has numerators that are multiples of 7. Now, here's a magic trick to turn this loop into a full integer loop. Just switch the rule from 3n plus 1 to 3n plus 233. And here that we take 919 as the bottom of the loop times 3 plus 233 over 2 is 1495, the next member of the loop. And even funnier, let's look at this old chart where the denominator is 13. We can turn all 7 of these loops into integer loops by switching to the 3n plus 13 rule. So instead of this, taking 211 over 13 to 323 over 13, we just get this, which takes 211 to 323 directly. So basically, there's lots of 3n plus r loops, and they all correspond to 3n plus 1 pseudo loops. And here's the craziest one. We have a loop length 27 here, and according to the 3n plus 5 rule, if you put in 187, you get back out 187. Now, if we were applying the 3n plus 1 rule to this same operation sequence, the looping number would have this denominator and this numerator. And oh man, almost an integer loop. We're just missing a factor of 5 in the numerator. If only 187 were a multiple of 5, we'd have had a 3n plus 1 counterexample. And when we switch to the 3n plus 5 rule, the new loop bottom turns out just to be the old loop bottom times 5, which in this case is 187, which is an integer. And now, since there's lots of 3n plus r loops, maybe we can see what makes them tick. And this gives us some more data to play with anyway. Okay, see you next time.